I'm going to be talking about RethinkDB. I kind of tweaked the title a little bit. Sorry, it was kind of last-minute thinking on this. I'm just going to come out and say, what is RethinkDB? It is, and what's with the name? RethinkDB is named RethinkDB because it was built trying to use the knowledge from NoSQL in years past. All the good things and bad things that Cassandra, MongoDB, and other systems like that figured out. RethinkDB came and said, well, let's think about this, and we'll kind of rebuild it, rethink it. That's the name. Also, every time I come over to Europe and I give a talk, I always feel bad because I'm a typical American. I speak English. Thank you so much for keeping up with me. But I did actually. This time I thought it would be nice to see if the organizers would help me translate the talk. So actually they did. And so it's my best Polish. What's so funny? See, for the other Americans in the audience, they have no idea the joke. I wish I could, no, I really do wish I could speak. I speak Google Polish, is what they call it, Google Polish. Okay, so in this talk, I'm going to do something a little bit different. So this is a talk I gave in Oslo, Norway, at NDC Oslo, and I didn't say a word. I didn't say anything. I just coded, because I wanted to give people the feeling of what it was like to work with Node. And I thought I could stand up there and wave my arms all day and talk, right? Or I could just do it. And it was really fun to do. I hate to say it, this talk's going to be the exact opposite. I'm not going to code. You are. So I've actually made this whole talk so that you could follow along. All you good people out there with your computers and your trays and your coffee, I'm praying that you guys will actually follow along, because I got inspired by Chad's keynote today where he said, let's take something home today. Let's put it in our pocket. Let's declare we actually did something, we executed, and we had a victory. So hey, why not make it this? Because it's easy and it's fun to do. So we're going to be kind of peer coding, so feel free to shout out politely. If you want, please join me. It's going to be fun. We're going to do this together. Now, you're going to say, I don't even know. I'm not on Wi-Fi. I've made it easy for you. That is the Wi-Fi code right there. If you're not on Wi-Fi, please get on it, because we're all going to crash the Wi-Fi right now as we download and install RethinkDB. It's on the back of your badge. Why? Why is this important? Why do you want to do it? Because check it out. What you're going to do today is you're going to learn how to shard, how to cluster. You're going to do this, right? You're going to create your own document database cluster, sharding, and this should be playing. Is it playing? It is playing. Good. This is easy to do. This is easy to do with RethinkDB, and that's one of the fun things about it. We're coders, right? We like building things. We like doing things. And if I do the talk right, hopefully you guys will experience some of that. If not, just look over someone's shoulder. You'll be a DB master. Okay, so let's quickly start out. We'll go to rethinkdb.com. That's the website. And you can take a look around. It's a gorgeous site, I think. Click the big red button, because that is the install, right? I can see all of you are playing along. Thank you so much. No, click the big red button. That's the installation. It'll take you to the installation page. I'll even make this easier for you people with Macintoshes. If you have Homebrew installed and you want to play along, this is it right here. This is all you have to do. Boom, let's crash the Wi-Fi. We could do it, right? We could do it. This will install RethinkDB on your system. If you're using Ubuntu or you have a VM that has Ubuntu on it, take this wall of text and put it in there. And then it should start installing. If you're on Windows, man, I'm sorry. Just you're going to have to kick up your VM. Don't get mad. Please don't get mad at me. It's what? Can you go 2 slides backward? Oh, yeah, sure. That one? Yeah. You're welcome. Sorry about that. Good for yelling out. Yes. Good. See, in Norway, they don't do that. They just kind of stare at you. OK. Anyway, Windows, it doesn't run on Windows. Sorry about this. But you have to ask yourself, why in the world would you put a database on Windows? That's a small opinion. Sorry, just sharing. All right. Brew install RethinkDB. You got it? All right. I'm going to move ahead. Sorry if I have to keep the talk moving. OK, straight out with it. Straight out with it. Why? Why RethinkDB? What are some of the facts that you guys are wondering about? I know you're wondering about this. The initial release of RethinkDB, it's not all that new. It was released in 2009. That is 1, 2, 3, 4, 5, 6 years ago. The current version is 2.1. The version that they said was public, supportable, production ready is version 2. So that was released just a few months ago. It queries with a functional language. Where's my F# buddies? Where are you guys? Yay, it's functional. Yes. It's really exciting. I'm going to show you ReQuel in a little bit. It is used widely in production. It actually is, but nothing notable that I could tell you, like, hey, it runs Instagram. It doesn't. anyway. So it is used in production every day, everywhere. Okay, I already showed you this slide, but I've been trying to stall a little bit while you guys are installing RethinkDB, so hopefully it's installed by now. You're at what? Where are those? What's wrong with the Wi-Fi? Oh well, we're going to keep going here, I guess. Hopefully it'll come down. This is the home page of RethinkDB, and to me, this is where the journey starts. Because if you look at this home page, it's kind of soft, beautiful, friendly. It's I don't know, it's welcoming. I guess that's the best thing to say. If you scroll down, it'll show you all the things you can do with it, all kind of the fun little gifts that just gives you a really nice introduction. You can click around to the docs, FAQ, you can look and learn about the API, and notice the tagline. This is the interesting thing to me. The tagline says, open source database for the real-time web. Neat. What does that mean? Well, it means that what they did recently is they pivoted. This was their site a year ago, and they used to be the open source database, distributed database, built with love. And the colors are a little bit harsher. And I think this is interesting because it shows the evolution of where they're going as a company. They're heavily funded, and they're trying to build a real-time system, a loving system, something that's easy to use. Contrast these two home pages. I think it's pretty interesting. All right, so for those of you who are playing along in your mind, let's pretend you have it installed. Hopefully it'll come down soon. You'll catch up, I promise. We'll talk. Okay, so the first thing, if you're going to play along, you want to make a directory to put RethinkDB data in. So we're just going to make a directory, make dir RethinkDB, or devday RethinkDB. The next thing, we're going to change into that directory, because this is where RethinkDB is going to live on your system, and then we're going to run it. That's it. So we run it, and what you should see is a big old splash of text. So this splash of text is kind of the next introduction, I guess you would have to RethinkDB. Every line means something. It's not just a bunch of blah. It means something, which I think is so fascinating. You can step through those lines, read what you like in there, but I think the most important thing that I want you to see are these three lines right here. It tells you it's listening on 3 separate ports. The first one, you guys have to remember this, there's a test on this later. It's listening for intra-cluster connections on 29015. You're going to remember that. I'm pointing you out. Yes, you're busted, yellow shirt. Okay, I'm going to ask you about this later. Client drivers listening on 28015, and then HTTP connections on port 8080. So what does that tell you? Someone, come on, shout it out. We have a UI. We have a website. So this is the next fun thing about this. Now, just kind of bask in this for a second. This is the next part of starting to use RethinkDB. Look at this UI. Look at the words. Look at what it says to me. I see this kind of thing, and I get really excited, as you can tell. There's not a word here that I don't understand. So if you ever installed React, or any other system, even Mongo doesn't have a GUI like this, but if you install other systems that come with their own GUIs, you have to kind of wade through this syntax dance. And you kind of have to figure out, like, what is a ring? I have no idea. Here, I know what a table is. I know what a server is. I know what a data explorer would probably do. To me, this is very nice. All right, so let's take a look at what you actually get when you, is it running? Sorry, one second. Is it going now? There we go. So this is the UI in motion. And if you scroll down here, look at these little ants walking by. This is your timeline. This is read and writes per second. This thing is live. It tells you the condition and the health of your database at any given time. This is a website, but is a real-time administrative screen. Now think about the databases that you've worked with before. Are any of them like that? No, they're not. Here I'm renaming my server, and I'm going to call it Fabfly Freddy. It's an 80s reference, and if you guys get it, hooray for you. Look up in the top left, or top left, right now. Did you see that change? So what happened is the UI told the database, you're changing your name. And the database said, all right. And then we had to wait for it to happen, but the UI didn't update until the database did. So what that should tell you straight away is that anytime you do any changes to your database, data, or whatever, the UI will then refresh itself whenever that happens. It doesn't have to happen on this screen. It can happen anywhere in your application or anything, which is pretty neat. There's other information up there as well. Of course, you can see cache size, uptime. It's very informative screen. OK, so here we're going to click over to the tables. And OK, bonus prize for you guys. How can I add a table to my database? Yeah, so it's easy, right? This is one of the cool things, add table. I can get rid of the database. This is a test database that you get for every installation of RethinkDB. You get test. There's a switch you can say no test if you want to kick up your server, and it won't be created. If we want to add a customers table, just click the little add table button. Boom, customers. And then it says it's ready. We're good to go. OK, so let's head over to the Data Explorer. And here, we are going to actually play with some data and do some queries and see REQL, their query language, for the very first time. Now, I know the first time people see this, they tend to look at it and go, oh, great, really, a text area? We're going to query in a text area. But watch this. This is really fun. Inside of our little text area, we can actually write some queries using the default namespace R. Everything flows from R. R is where all the functions come from. And inside of here, we can actually do some fun things. And look, IntelliSense, woo! This is actually more than IntelliSense. It's actually a learning tool. It tells you everything about what's possible. So here, I want to actually play with a database. So I have to specify which database I want to play with, and it's going to be one of those in that list. There it is, RethinkDB or test. It actually tells you which databases are available to play with. So we have RethinkDB, which is the system database, or test. And then once we do that, we can do a few fun things, such as creating a table using the table create function. Sorry, the resolution on the screen is not so good. Hopefully you can see that. Here I'm just saying create a table called products. Execute that query, wait for just a second, and boom. Down here on the bottom, we get a change set. Notice it didn't just say, OK, right? It didn't say success. It gave you a change set, which I love, right? And here is the next thing that I think is absolutely fantastic. Durability is set to hard, which means it will not acknowledge any writes to your tables until they have been written to disk, which is big. MongoDB does not do that. MongoDB actually wants, never mind, I'm not going to go off of MongoDB. MongoDB, actually the default for MongoDB is to just acknowledge that the write came in, and then it might write it to disk, and it might not. I'll just leave it there. So durable by default, that is a huge thing. And this kind of brings, let's go back now to the RethinkDB and what the creators of RethinkDB were thinking. They want the best of both worlds. So they took a look at MongoDB, right? And they took a look at something like Couch. Insanely easy to use, fun to play with, but when you scale up, yeah, that's when life gets kind of fun. On the other hand, you have things like React and Cassandra that are really hard to use in the beginning, kind of steep learning curve, but as far as operations go, they're fairly bulletproof when you get to scale. So they're trying to hit it right in the middle. They want fun, easy to use, and then also big scalability. So if I had to rank all the things that we kind of just talked about here, how would I rank that? I can't tell you how important it is to have hard durability straight out. It's one of those things. They care about your data. That's something that to focus on immediately. Sharding is incredibly simple, as you're going to see in just a second. Automatic failover, you can do it. It's not so hard. And then finally, a friendly, gorgeous UI. I just put that at the bottom because it's not really necessary, but they give it to you anyway. OK. You would think that I'd be building up to the sharding and replication and building out a cluster. You'd think I'd build up to that. It's just so easy. Why not just do it right now? It's not a very big deal. So if you've got it running on your computers right now, it's still what? Great. Oh, well. Sorry. OK, so let's pretend in your mind. Imagine. We're going to change back out of directory. We're going to leave the initial server running. By the way, if you guys want to do this later, I will have all the steps for you. Come up. We can hang out. We'll play. It'll be a good time. Just create it in a new directory. Create a brand new server instance in a new directory. The command that you want to give it is this one right here. You just want to tell it to offset its default ports, those 3 ports we talked about, offset by 1. So instead of, what was that port number? 29015. Very good. I've covered for you. Don't worry about it. 29015. So we're going to connect using localhost 29015, right? But the server we're creating is going to be on 29016 because we're offsetting it by 1. Once you do that, you will see another wall of text. So that wall of text is again going to tell you all the same things. There's lots of things going on here that we can dive into later. But that's the big line right there. We just created a cluster, just like that. Just with that one command, saw the other one, saw it on the port, created it. If you had the UI running, you would see immediately up at the top, boom, it would have refreshed and said, there are now 2 servers available in our cluster, which is pretty cool stuff. Again, think about this. If you've ever used a GUI like SQL Server's MMC, Postgres, Navicat, or any other kind of database GUI, let's say you created a table and you have the nice little table tree on the one side that shows you all your tables. How many times have you actually created a table and seen it refresh on the left side in the tree? Well, I don't ever see it myself. This is reactive, and I love that. I think that's really, really, really nice. OK, so let's do the same thing here. I'm going to now rename my second server, because right now it's just kind of this amalgamated name that it just makes off the name of your machine, and then it creates a server with just a mangled name. So we don't have to be GUI dependent here. We don't have to rename everything here. I want to show you how you can actually do this in REQL with command functions right at your fingertips. Gotta make sure this is running. It is running. So here, what we're going to do is we're going to open up the system database. And it's available to you straight away, and it's called, surprise, RethinkDB. And so in here, notice how that list is refreshing each time that we put the dot on there. It tells you, oh, you want to look at the table, you want to look at this and that. It actually refreshes and shows you. Here's all of our system tables. And the one that we want is server config. And what server config is going to do is it's going to let us take a look at the configuration settings for each one of the servers in our cluster. So here I just run this query, and you can see I have 2 documents. I have the IDs and the names of each one. And you might be thinking, Rob, is that really a smart thing to do? Crack open the system database? Well, I don't know. Let's see what happens. So to get at an individual document inside RethinkDB, we just have to grab this big fat GUID. Take this GUID, and then we go back up to our query right here, and we say get. Get is just, this is a document I want to get. It's going to get a document. I put in the ID of that document, and boom, up it comes right here. We are chaining operations together. That's how REQL works. I have another operation I can perform here, and here's all the choices I have that I can work on an individual record. So notice the IntelliSense changes. I want to execute an update, so I'm going to use update. And look at that. It tells you everything that you can do in an update. It tells you how to execute it. This is the flavor of working with RethinkDB. This is the idea of rethinking these databases to make them super friendly and fun and nice. OK, so I want to change the name of the server. So that means I just need to say name and then put in the new name. This is a partial update of a document, which RethinkDB supports. If I wanted to replace the whole thing, I would just say replace. So here I'm going to mangle another hip-hop artist of the 80s name, call him Freshy Doug. You guys probably have no idea. I know Chad knows who he is, Dougie Fresh. Anyway, so yeah, I run this, and down below I get another change set. It tells me what happened. Not only did it tell me what happened, it told me what didn't happen. I'll talk more about that in a bit. OK, going back to our table screen, or our server screen, we now have an updated database name. That was not too hard. I don't think it was, at least. All right. So do you think it's a good idea to play with a system-level database? I don't think it is. Do you think it's all right? Some people can do it. It gives me the willies. But just for the sake of fun and breaking things, let's go and mess around and see if we can actually break RethinkDB. Because I could stand here all day and tell you how awesome RethinkDB is, but until I try and break it, let's see what happens. Here I'm just going to try and add a key, an arbitrary key, to our server table, and it won't let me. It says I don't know what thing key means. I don't know what it is. It has the wrong format. OK, notice down here we have some tags. Each server can have a tag. Let's go up here and try and just set a tag to an arbitrary string, instead of just adding a key. If I try and do that and set the tags to stuff, it'll stop me again. In fact, it won't let me do much of anything. So it's smart enough to not let you destroy your database, which I like, because I like to destroy databases. OK. Let's move on to sharding, because I said we're going to talk about sharding, and I'm not really doing that just yet. We actually need some data. So let's add some data. So I know that we're having download problems, so just pretend that we're adding some data. This is the way you insert a document into RethinkDB. You start with the default core REQL namespace, R, And then from there, you narrow down the database, you narrow down the table, and then you execute the operation, insert, and then you give it a document, and it goes. We're going to have some POI in our database, which I think is nice. And then notice down here, again, I mentioned this before, but notice that change set. This is something that I find so useful because it gives you some guarantees. It tells you that one document was inserted. It tells you the keys that were generated, and it tells you that nothing else happened. So it gives you an exact idea of what you just did. The generated keys right there, notice it's an array. I could have passed in, instead of a single object up there, an insert, I could have passed in a huge array of documents, and they all would have gone in transactionally. Okay, so we'll add a second document in here, poke. If you guys ever been to Hawaii, poke is awesome, so is poi. I know that Matt up there loves both together. Okay, so now we have 2 records in our database, and now we need to shard. And this is going to be some fun. I think it's fun, at least. So how do we actually shard and create a replica set in our cluster? Because we have a brand new cluster, and that's not running. Let's see, 1 second. Whoops. Is that running yet? There we go. Okay, so we have 2 records in our database. So from here, we want to actually go over to the individual table that we want to shard. Now notice it's on a table. That's a table operation that we do it. This is the table screen, and it tells you lots of information that we have about 5 documents. I don't know why it can't be a little more accurate. Down below, it tells you the throughput of the table, the little ants marching across the bottom. Down at the very bottom here, it tells you the shards and the replicas that you have. And we can just change it by going to reconfigure. Notice down at the bottom, you can't really see it, it's a little bit blurry, but it says you have a maximum of 2 replicas and a maximum of 2 shards. It's because we have 2 servers. We can just change it, and as we change it, look down below. It tells you where your data is going to go. Just like that. That's it. And when we're done, we hit Apply Configuration, and this is where the fun starts. Once you hit Apply Configuration, nothing seems to be happening except you see a little spike up there. It tells you the read writes, it's shoving data around. Then all of a sudden, just like magic, boom, there goes your shards. Just like that. And we're done. We just sharded and created a replica set on 2 different servers. Now, if you're not up on what sharding and replica sets are, just a quick one on that. If you have data that you really, really care about, like our products, right? And you want to have some redundancy on that because you want the querying to happen quickly, and you also want to have some failover. So you want to be able to have redundancy maybe around the planet. You might have servers, let's say you have a worldwide e-commerce site, products you want to display to people. So you might have servers in Asia, Europe, East and West Coast of the United States. So you might put a RethinkDB server in each one of those locations. And then what you can do is create instances of a server, and then you can replicate your products table all over to each one. That way, when people come in and visit all over the world, you're able to get the data back to them really fast. Conversely, if you have a ton of data, and it takes time to query, let's say you have millions of records, and it takes a long time to query because you have a lot of stuff to cycle through, you could split that table into 5 bits. So you have 1/5 of the data in each one of the shards. That makes querying faster. Anyway, that's what we're doing here. You saw how quick and easy it was to do. There's a lot of strategies you have to build in there. Congratulations, you are now a document database DBA. It takes, I mean, seriously, have you ever tried to do this in MongoDB? Tried to do it with Postgres, MySQL, trying to do it with any other system. I've never seen anything go as fast as this. And seriously, if you guys could have downloaded and played it, you would have been able to shard and do all these things with me. Oh well. So where are we right now? Let's kind of just take a quick break, and I told you 4.5 reasons. I think that's what that second slide said. I'm not really sure, because it was in Polish. You're going to have to ask Mikhail what it said. Anyway, revisiting our reasons. What are the 4.5 reasons? Number 1, it's easy, it's simple, the UI is gorgeous, it kind of just invites you in every step of the way. It is there to help you out. I think that's great. Durability by default, I can't emphasize that enough. Your data is the most important thing here. Not the UI, not anything else. And it's simple to cluster and shard and fail over. But there's the fourth and a half reason, and I haven't really covered it, so let's do that now. You've kind of been seeing it as I go along here, but the query language itself, REQL. It's a little bit hard to kind of grasp it when you start playing with it, but once you start playing with it, it becomes more and more fun. It's kind of like F#. Yeah, throwing my buddies a bone for the F#. Okay. When you want to get started with ReQual, it's simple to do. You just go to the RethinkDB site, hit Docs. It takes you to the page here. You have a 2-minute guide, 10-minute guide, 30-minute guide, hand-holding guide. You have a sequel to ReQual cheat sheet. I have to say that carefully. And then it helps you get started learning ReQual and how it works. At the basic level, this, as I keep saying, is a functional pipeline. When you're working with ReQual, you're basically tagging on operations, you're getting some data out, you're transforming it, you're doing the things you need to do, and you just keep tacking things on. It's embeddable. That's the thing that's also important to understand. ReQual is embeddable. They've made it so that you can actually write queries in the GUI, like we did before, right here. We wrote it right in the GUI. And you can take it and copy and paste it and drop it right into your code. Just because the drivers that they've created mirror what you see here. And I think that's really neat. So you'll see some node code later on that is almost exactly what you see right here. So figuring out what to do is a matter of reasoning it through. So if you can say it out loud, which I always tell people, just say it out loud. What are you trying to do? Well, I'm trying to get this record and delete it. There you go. Go get it, delete it. And pass in the key, and you're good to go. If you want to grab more than one record and use a filter, you just use the filter function, and you pass in the criteria. Here we're grabbing all the food, and we're deleting it. If you want to limit one, use limit. If you want to skip over one and grab the next one in line in the category food, this is how you do it. You get the idea. The order of operations is important because this is a functional pipeline, right? So here, see if you can reason through what we're doing. Just by reading this. I formatted it just so, but you should be able to read the name of each function and understand what's going on. All right, so I'll walk you through it. We're grabbing the products table. We're filtering by the food category, so all the food products in the database. We're ordering it by price. So that's an ascending order, so we'll get the cheapest at the top. We're going to skip over the cheapest and grab the second cheapest one, and we're going to pluck the price field. It's not rocket science. It's simple to do. You want the max price for the food category? Max. You want to delete all the products in your database? You can do that. So ideally, I was going to have you guys do that, but it sounds like the installs are not going off well. So let's just skip ahead to a little bit more complex queries, rather than just simple lookups and stuff, because those kinds of demos drive me crazy. Here we're going to get a big bugga of poi. So if you ever go to Hawaii, you're going to want a big bugga of poi. Trust me. Or if you want to just have a little light lunch, you can have small kind. And this is going to put in a document here, and it's going to have variants on it, an embedded array. The reason why I want to put in an embedded array is because I want to show you how hard it is, or easy it is, to do more intense queries. Let's have another product go in. So this is going to be poke again, and this time it's going to have two variants, one for lunch and one big one. My first task here is I want to do some roll-ups. I want to do some roll-ups on this table to figure out what, if I had to add up all the prices together of our products, how much would that be? And then I want to find out the average price of each product. So thinking about this and reasoning it through, if you had to guess at what functions we'd have to chain together, see if you can do it. I'll tell you the first one, you probably don't know how to select the variants, so I'll just show you that straight away. To select individual fields inside of a document, you just tack on the parentheses. Now, it would be great if they could have dot notation here. That would make a little bit more sense, but dot notation would kind of make you think that's part of ReQual, so it doesn't quite make sense. So they just basically tack on an additional bit of parentheses here. So here, as you can see on the results down below, we're able to pull out the individual variants. This is the same as running the map functions. They have map. It works just like you would find it in JavaScript. It'll just return an array matching a certain criteria. Here, the criteria is just simply the variants themselves. If I wanted to only pull out the food category variants, can you guess how I do that? I just drop in filter right above map, right? So it's going to filter and it's going to map it out. Okay, so the thing I'm interested in is the price of each variant. So the next one here, I'm just going to ask for price. And you notice on the far right over there, I just tacked on price onto the map statement, variance price. But now I have a problem. My problem specifically is that those are in array format, right? I can't just roll up on individual arrays. That wouldn't make sense. I'd get an error. What I really want is I want the individual prices to come out per row. So for that, I have another function that RethinkDB comes with. It's called concat map. It's actually two functions in one. And what it's doing is it's running a map. It's pulling out what we asked for. But the concat part actually peels the array off and concatenates all the results together. Very useful. And you can see over here, now we have individual rows with numbers. All right, I'm going to put somebody on the spot here. If I wanted to sum this up, anybody have a guess how I would do it? Oh, I love you guys. That's it. Bam. Sum. It's not that hard. You can figure this stuff out. It becomes so simple to do. Okay, average. Anyone average? All right, that's an easy one. Just dot average. That's it. We have our numbers now. It's just dot average. Now, if you want to know, okay, Rob, in the real world, what does this really look like? So this right here is a real sales roll-up on a real sales document, a Shopify document. I downloaded and I used I used a node module called Faker that generates a ton of fake data for you. And I created 1 million records, 1 million sales records, and I put them into RethinkDB just to see what would happen. Because I like to break things, it's fun. I wanted to see how hard it would be to do a real sales query, something very real. And when you look at this, at first it's a little bit eye-crossing, and I know the resolution is not the greatest, but as you step through this query, it's not too difficult to figure out what's going on. I'll just talk about a little bit of it. In the very top up there, I'm using concat map. You've already seen this. I'm trying to pull the items out. The items is an embedded array inside of each sale, right? So concat map is going to bring those out to their own line. Then from there, I'm limiting by 1,000 so I don't break things. I'm using a group function that's going to group by SKU, and then from there I'm reducing it, which is another fun thing in RethinkDB. Reductions in RethinkDB are sequential, left-right sequential. Why is that important? Well, if you've ever done MapReduce in MongoDB, MongoDB does a functional MapReduce where you just have to return the reduction that you want, and it works basically on one node, and then it goes and applies it to another, and then another. RethinkDB's MapReduce works across the cluster in parallel. Let that bounce around your mind for a little bit. Why is that a big deal? It's because if you have a big fat cluster, you want things to execute in parallel because it's faster, right? You want it to happen concurrently. So that's the way MapReduce works in RethinkDB. It's absolutely fascinating. Anyway, this gives you a nice roll-up at the very end. So that's what a real RethinkDB query looks like. Okay, so this is kind of the half part of 4.5. Let's talk about changes in the database, or change sets. This uses REQL, so it's kind of part of the last one, kind of not. Okay. We want to listen to changes that are happening on our customer's table. Can we reason through this together like good developers, good geeks? The first thing I need to do, I'll just give you a hint how you get started. The first thing I need to do is to actually grab the data from the customer's table. I do that by using RDB table customers, right? That's going to drop all the customers out so I can see it. But now what I actually really want to do is listen to changes. Can you guys guess what the next function would be called? Someone said it. Changes. So you listen to changes, and now you can see at the very bottom down here it says listening for events. Now I showed this to somebody once, and they said, wouldn't listen be a better name because that's kind of what you're doing? That's a good point. The reason it's called changes is because that's what it returns. So remember, this is functional. You're wanting to know what the function is going to return to you. And so what it'll actually return is a change set. So let's see this in action. Really predictable demo, side-by-side GUIs, right? You know what's going to come, but I'm going to show it to you anyway because I think it's important. Here I'm just going to insert a new record into our customers table. It'll be me, test@test.com. And what I want you to focus on most is just what is returned on each side. So over here when I run this, you can see they both go off, of course. Over here when I run this is what we've seen before already. It's the change set. Over here is something completely different. It tells me the old value. There's an event that came in. The event has an old value and a new value. And the new value is the record itself. So when you're listening, you're not kind of left in the dark. You actually have all the data come back, including anything that has changed. And I really like the response here. I love it on both sides. They're so concise. If I go and delete it, it tells you over here, one record was deleted, nothing else happened. And over here, the new value is null because there is no new value. The old value tells you what the customer record was. Okay. So this is what it looks like in Node. People here use Node very much? Anyone? No? Okay, some people do. So this is JavaScript, right? And so this is how you use RethinkDB in Node. I require RethinkDB, var r, r is the root namespace, right? I connect, and I'm given a callback, right? And the function that I have to use itself is the exact function that you just saw. So if I write this out, it's going to be r.table. I don't need to specify the DB because it's in the connection string already. And I'm going to execute the function, changes, and then I have to tell it to run. This is a thing you have to do in Node. You have to explicitly say run. Then I'm going to grab the cursor, and I'm going to say for each thing that comes in on the cursor, I'm going to output it to the screen. So if I go over to my console, and it's kind of as you would expect, I just tell Node to execute changes.js. You've kind of already seen this demo, but I do want to just show you that here I'm in the GUI, and I'm changing something. And then over here in my console, boom, out it comes. The changed record. So Skippy the monkey was renamed to Larry. No, I got that backwards. Larry was renamed to Skippy. Okay, by this time, people should be kind of scratching and itching, saying, yeah, but, my database, yeah, but. So let's talk about this. If you're a Postgres fan, you will say, but you have notify and listen, and you PG notify, and that's pub/sub built into Postgres, where you can notify a channel that something's saved and dump in some data, and then you can have a listener, just like you just saw. If you're a SQL Server fan and you like smashing your face against the ground trying to get this kind of thing to work, you can. It's not fun. You can also do this in MongoDB, but what they focus on is pub/sub, and that's different because you have to actively publish what you want to change. You push it into a channel or to a room or whatever they call it, and then you have to send the data along. Same with PG notify or notify. You have to notify and send some data along to a given channel. That's not what you just saw. You saw change sets being pushed out to anybody that's listening to the change sets. So I think that's really important. Well, I have to say, I had 70 slides, and somehow I actually ended early. I don't know how that happened. Told you. So, RethinkDB, 4.5 reasons. I don't know which one is the half part, but the reasons that I like it and the reasons why I think all of you might want to try it at some point, as you saw, it's simple to install, easy to administer, the UI is gorgeous, it's incredibly helpful, it helps you every step of the way, even if when you try and actively destroy it like I just did. Durability by default, I can't emphasize that enough. I think it's incredibly important. Simple to cluster, simple to shard, you just saw me do it. There are more advanced strategies. I could spend an entire talk on sharding and clustering. It's a lot of fun. And the last thing is the REQL. The language itself, it's tons of fun to work with. And you know what I forgot to mention? I should mention this too. REQL works on the server. It doesn't work on the client. So everything you just saw me do, I know it looks like JavaScript. It's not executing and then like telling the server what to do. The whole command is actually crumpled down, sent over in binary format to the server, and it's executed there. And that's really important to know. Anyway, that brings me to a close. Thank you so much. Please ask questions if you have any. And that's it. Transactions? What's that? Transactions. That's a good question. How can I answer this best? No. But, no, I said that sort of facetiously. It depends on how you think about a document. So for a lot of people, they encompass a transaction in a single document, and they'll work on that later. So the sales document I told you about before, it's from Shopify, and it was literally their document that I just kind of tweaked and mangled. But everything that you have in that sale document, it's like an event source if you're into event sourcing or CQRS. It is actually the event and all the data that went into it. So it's the transaction in that document. And so that's the way a lot of people actually think about doing documents. Does that answer your question, sort of, a little bit? It's not a transactional system. Well, it's not ACID-based. So if you're trying to look for transactional systems like that, yeah, it's not going to do it for you.
So can you give an example of the system where we can use it? For example, RethinkDB, or maybe there is a system where you use it
in the real world. That's a good question. My friend Nate Kohari, who's building his site, TaskTorch, he's using RethinkDB as the database engine, and he does a lot of real-time back-end work on it. So he's listening to change sets on particular tables. The real-time updates the UI. So if you ever use anything like Meteor, do you guys know what Meteor is? It's a real-time web framework. But real-time is like a big deal these days. And so for if you have, let's say, a website, mobile, maybe an iPad, desktop app, and you want to push data around, you can have RethinkDB power that easily. You can have it really enterprise. You can have it anywhere you'd have a database. Did I answer your question? Well, the question was, where would you use it? I should be repeating. Sorry about that. Anybody else? Question? Yeah. Yep. No. The question was, do you have full text search? No, the team's working on it, but they do have what's called a river. I think it's called a river, an Elasticsearch. So what a river is like a plugin to Elasticsearch. So if you had an Elastic engine, you download and install the RethinkDB river, and it just points over, and then it literally fire hoses the data back and forth. So you can use Elasticsearch, but that is a downfall. I'm going to talk about full text indexing tomorrow, Postgres talk. I'm actually bringing this up. Yes? Accessible to your code, the API? Yeah, mm-hmm. Yeah, I see what you're saying. So the question was, can you make calls against the same API that this the website, the web code is using? Yes, it talks to the exact same thing. It's calling to port 20815. So yeah, it all bounces everything. All the things that you saw that website can do, you can do in your code. In fact, the people that use this in the wild actually just set up their own scripts to run in Node or whatever else, and then it just pumps the data in and out the way they need. So like if you're managing a cluster, you wouldn't want to go in and use the UI to kick up a cluster. You'd want to have a set of scripts to it for you. Okay, let's see, way in the back, yeah? You way in the back.
I saw that the syntax is very similar to JavaScript.
Yep.
Is it the same, or are there any differences?
It is really, really close. There are a few differences that you'll notice, but I'm trying to think of an exact example. Well, for instance, you can't just arbitrarily drop in braces where you want. Like you saw with the variance thing, I guess for all intents and purposes, you can think of it as JavaScript, but it's not. But what I'm trying to add here is that it will actually decipher JavaScript for you. So what I didn't show is there's an r.js command where if you can't think of what to do and you want to drop into JavaScript, you literally can just say r.js and then put in for loops and everything else you want, and it'll actually translate that for you into your query, which is pretty wild. But it's not, there's some nuances, and I can't remember what they are off the top of my head. Did I answer your question? Okay. Yes?
Could you just show us that we can use implementation Node.js
Uh-huh.
about other languages or platforms?
So the question was, does it support other languages and platforms? Yes. There are drivers for .NET. There's drivers for Java. There's drivers for Python and Ruby. Yeah, I think a whole bunch. There's one that was just made for Elixir. Yeah, there's a whole bunch. They're out there. Yeah. Anybody else? Let's see. You had your report. I'll come back to you. Yeah.
Sooner or later, most of you have to start with
Yeah. Dang it. You know what? I had this as a slide. So the question was, you have to do a trade-off. You can't have all three. So if you know CAP theorem, and I'm totally blanking, consistency, availability, and partition tolerance. Thank you. So with RethinkDB, I believe they chose the C and the P, consistency and partition tolerance over availability. I might be wrong about that. But you can't have all three in a document database or a distributed system like RethinkDB, which is a bummer. But so they made an active choice to go a different direction than MongoDB, and I believe MongoDB chose availability and partition tolerance. Am I right on that? Yes. So that's one of the big differences. That's what moves RethinkDB kind of over into the middle between React, Cassandra, and Mongo. All right, you had your hand up. Yes.
What about privileges for database users?
Well,
Privileges for database users.
yes.
Privileges that some users are not allowed.
Yes.
For host operation.
Absolutely. The question is, what about privileges and safety and security and all that in each database? And there are, yeah, you can lock it down. I didn't show any administrative stuff, but what most administrators do is they do everything through the command line. So I believe there's a REPL that you can use, but you saw the RethinkDB startup commands. You can send in just about everything. You can also go into the database itself and configure all the access right through the GUI using the RethinkDB database. So yeah, it's highly available for that. Plus, if you don't want to run your own, there are companies out there like Compose.io, which used to be Mongo HQ. And so if you want to just play with this right now, you can go to Compose.io. They give you a free account. You can log in. It boots up 2 RethinkDB servers for you to play with straight away. It handles all the management, backing up, and everything for you, and you can have a good time. And it also gives you port forwarding, so you can play with the GUI straight away. Let's see, what time are we? What do we got? We're done? Oh yeah, just one more question. I know they're working on it, but I know I think they're working on it. That's what I heard. I might be wrong. I know it's something they're considering, but it's just the audience isn't there is the problem. Sorry, don't get mad. Thank you guys very much.